Welcome back to the Deep Dive. Today, we are stripping away the noise and focusing on a scenario that is, well, it's effectively a refrigeration unit's worst nightmare.
It really is.
We're breaking down alarm code 12, which is technically known as sensor shutdown.
It might sound a little dry, but in the field, this is absolutely critical. When code 12 triggers, your unit isn't just, malfunctioning, it has lost its ability to perceive reality.
So it doesn't know the cargo temperature.
It knows nothing. Not the temperature of the cargo, not the temperature of the air it's blowing out. The unit is, for all intents and purposes, blind.
And the documentation calls this a cascading failure. It's not something that happens in isolation, right? For the unit to go fully blind like this, you need a very specific set of conditions.
You do. Code 12 is actually a result, not a root cause. It only activates if you have two other specific alarms active at the same time.
Which are?
Alarm code 03, that's the failure of the check return air sensor, and alarm code 04, the check discharge air sensor.
Okay, so you lose the sensor watching the air coming back from the cargo.
Right. And you lose the sensor watching this super cold air blowing out.
Precisely. It's like a pilot losing both their altimeter and their windshield in zero visibility. The unit cannot see the air coming in or the air going out.
And that's where the engineering gets really fascinating, because the firmware has to make an immediate autonomous decision.
It has to fail safely.
Right. And that decision isn't static. This was the biggest takeaway for me. The machine's reaction changes completely based on what you're hauling.
Context is everything. Let's take the fresh scenario first. Say you're hauling lettuce or maybe sensitive pharmaceuticals with a set point of, 34 degrees Fahrenheit?
A typical fresh load.
Exactly. If code 12 hits in that situation, the unit treats it as a hard shutdown alarm.
It cuts the engine.
Completely. The unit just stops.
That feels aggressive. You're hauling sensitive cargo, the unit goes blind, and its solution is to just stop cooling altogether.
It's a calculated risk. Think about it. If the unit keeps running without knowing the discharge temperature, it could easily top freeze the load.
You can destroy a shipment of flowers in just minutes by blasting them with air that's too cold. So the logic is the cargo is safer slowly warming up than being subjected to unchecked, potentially freezing air.
So it chooses the risk of spoilage over the certainty of freeze damage.
Yep.
Okay, but then you flip over a frozen set points, ice cream, things like that, and the whole logic inverts.
Exactly right. If you're in a frozen range, code 12 acts as a check alarm, not a shutdown. The unit keeps running.
Oh.
It forces itself into what's called continuous low-speed cool.
Because you can't really overfreeze a block of ice cream, can you?
You can't. If the cargo is already frozen solid, the danger isn't making it a bit colder. The danger is letting it melt.
So it defaults to just keeping things cold, even if it's blind.
It prioritizes preservation over precision. It just runs on low to maintain a baseline of cold air until a technician like you can intervene.
It's a brilliant piece of fail-safe engineering, really. But let's shift to the workflow. You're the technician, you're standing at the trailer, you see code 12 on the display. The instinct is to start troubleshooting code 12.
And that's a trap. It's a total distraction.
You can't fix it directly.
You can't. Remember, it's just the messenger. It's telling you that sensors 03 and 04 are dead. You have to ignore 12 and hunt down the root cause of why those sensors failed.
And since it requires both to fail at the same time, you're probably not looking at two sensors that just happen to break at the same second.
Highly unlikely. You're looking for a systemic issue. A cut harness, a big electrical spike, maybe a loose connector block that affects the whole sensor circuit.
So this is where the diagnostic data comes in.
This is where your laptop becomes your best friend. You need to hook it up, open WinTrack, and download the Service Watch data logger.
And dive into the technician user level data specifically, correct?
Yes, you need that granular view. You're looking for the exact conditions at the time the alarm was set. What was the voltage doing? Was there a vibration spike? You need the context of that moment to see what knocked out both eyes of the unit at once.
And then the resolution. What's the protocol?
It's simple, really. Once you fix the underlying issue, you replace the sensors or repair the wiring for codes 03 and code 04.
Code 12 just disappears.
It clears itself. It's self-resolving. It only exists as long as that double failure exists.
It really just highlights how much logic is hidden behind a simple error code.
Yeah.
You've got a machine making these high-stakes trade-offs between shutting down and running blind.
All based on a single set point number. It forces us to trust that the engineers understood the physics of the cargo better than we do in the heat of the moment.
Something to think about for everyone listening.
Yeah.
We often see these units as just cooling boxes, But code 12 proves they're really risk management computers that just happen to have compressors attached. Thanks for listening to this deep dive.
See you on the next one.